Hi, in this class we will learn about 5G spectrum. So as 5G is a technology which offers high data rate, so we require spectrum capability to hold data rate up to 10 gigabit per second. So for 5G we have a band from 1 gigahertz to 100 gigahertz. So we have a sub bands which ranges from 1 gigahertz to 100 gigahertz within a category of this. So if I make a band extending up to 100 gigahertz, so this is my 1 gigahertz. Then I have 3 gigahertz. From 3 gigahertz, we will have 10 gigahertz, 10 gigahertz to 30 gigahertz, and so on up to we have 100 gigahertz. So this is the band specification that we have a band ranges from 1 gigahertz to 100 gigahertz. Now as this much band, that means up to 6, I can say up to 6 gigahertz. So this is band which is LTE compatible. So up to this we have LTE compatibility. So from that we can say that this particular band, so on up to extending up to 100 gigahertz, can be used for 5G access. So focusing upon 5G access, so we have here multimeter wave propagation. So we can say that extending up to 100 gigahertz, we have 5G mmW axis, or we can have multimeter wave propagation axis which extending up to 100 gigahertz. Now this LTE compatibility, or up to this band, why this is LTE compatibility, this can be used for 5G. Now where this band can be used for 5G? So for 5G cellular access, where we require high performance and wide coverage area. So for within this band we require high performance and wide coverage area, which means that up to this particular band, which I can say as a lower band, if I use this for 5G cellular access, so we can have high performance and we have wide coverage area within a specified limit of this particular band. But as we require low complexity design and short range, that means if I require this much particular band, so there will be low complexity, because this much is not compatible with LTE. So we have very less complexity, but we have short range. And I can say that we can achieve big data in this. So band are divided into a lower frequency band and an upper frequency band. Up to this band we can use for a wide coverage area. But my design, that means my 5G specifications or requirement should require these particular band, because we have an mmW axis as well as we require big data and high mobility. So we require more bandwidth to cover up those requirements. Now, from 10 gigahertz to 100 gigahertz, this much particular bandwidth is required, or from 10 gigahertz to 100 gigahertz mmW is required, or it is needed for multi-gigabit per second. So why I have specified here as a multi-gigabit per second? So I like 2 gigabit per second or 3 gigabit per second or even 10 gigabit per second. So this much bands from 10 gigahertz to 100 gigahertz we require for multi-Gbps, or if for 10 gigabit per second we require 100 gigahertz of frequency. Now we have another provision, and that is shared access technology or technique. We also name it as shared access spectrum to increase that also. So that means we have a provision to have increase in availability. For an increase in availability, we can use the shared spectrum as well. Now, flexible duplex. We have a concept of flexible duplex between uplink, that means dynamic uplink, and dynamic downlink, which is specially for small cells. So, we have a concept of small cells in which we are giving dynamic uplink and downlink. That means changing uplink and downlink, and this technique of dynamic, not fixed. We are not having the concept of fixed uplink and fixed downlink. We are using concept of dynamic uplink and dynamic downlink. Now this technique is known as flexible duplex. Which can also be used in 5G cellular access to achieve high data rate. Now, if we have a comparison of each and every parameter which are related to spectrum of previous technologies till 5G. So, let's have a graph. Look. So we have technology, and technology we will start from 3G as a third generation. We have after that HSPA plus, high speed packet access increased. We have LTE, then we have LTE advanced, and after that we have 5G. Now let's compare the bandwidth, which is in very first factor, and the bandwidth in units in hertz. So we have 5, and that is a fixed. In HSPA plus we have a 5 megahertz. In LTE we can have extended up to 20 megahertz. Whereas in LTE advanced, with the help of carrier aggregation, we have achieved a bandwidth of 100. Whereas in 4G we have a TAM of 100 plus. So we are going to increase the bandwidth more and more. Now peak rate, if I compare peak rate here. Now peak rate, for first we will compare in Mbps. Peak rates are the maximum achievable data rates. Now here we have 2 Mbps as a peak rate, 42 and 11, where 42 is for downlink and uplink, and Mbps in HSPA plus. Then we have 326 and 86. In LTE advanced we achieved gigabit, 1 gigabit per second, so 1000 and 375. Whereas in 5G we require 10,000 and 5,000. That means we are achieving or we require 10 gigabit per second as a downlink and 500 Mbps or 5 gigabit per second as the uplink speed in case of 5G. Now coming about the third factor, which is my latency in the network. That means the time taken to interact. So we have a 50. This is in millisecond. Then we have 20. After that we have 10. Same as 10 millisecond as a latency. Now we are achieving towards 0.1 to 1 milliseconds. Because as we are moving into technology, 5th generation, so we demand technologies, virtual reality and self-driven cars. So my latency should be very less as I want, and latency is 0.1 to 1 millisecond, which is a desired one. So this is the comparison of the previous from 3G till 5G, in which we have shown the bandwidth and accordingly the data rate plus their latency. Now let's have a view of 5G and spectrum. So I will make a graphical view, and on that graphical view we can see the bandwidth as well as the latency and other parameters. So starting from 1 gigabit per second. After that, or 1 gigahertz and 3 gigahertz. Then we will have 30 gigahertz. From 3 to 30, this is a graphical representation. Then we have 60 gigahertz, 90 gigahertz. So this one has 100 gigahertz as my extreme point. Now we are going to compare first parameter, and that parameter is bandwidth. Now bandwidth. So bandwidth, and this bandwidth is in gigahertz. So we have like first graph. Then we have my second peaks. After that I have my third peak and fourth one. This shows the bandwidth requirement less, more, and more, and it keeps on increasing. Now up to this, that means from 1 gigahertz, this one of the spectrum, this spectrum within a range of 1 gigahertz, and also we have from this to this much. So spectrums are divided like licensed and we have unlicensed. We have licensed as well as unlicensed. So if I combine together, that means I'm combining my licensed plus unlicensed spectrum together. So together, if these are my licensed and unlicensed, I will share this, and this is called shared spectrum. Because my focus or my aim is to increase the capacity, is to increase the speed. So licensed and unlicensed spectrums are combined together, so we can have speed desired which we want, that means up to 10 gigabit per second. Within a range of this, I have a bandwidth which is less than 100. Within a range of this, I have a bandwidth 100. Here we have, less than 100. Then we have achieving 100 plus, and in this category also we are demanding 100 plus. So moving of the That means as we are moving towards higher frequency range, so we are demanding more bandwidth in this. As the second factor, which is the speed factor. As I'm a range of this, I will get less speed, and when I move away from it, I will obviously demand more speed. So I will say that I have a speed of 10 to 100 I can expect, whereas here I can expect 1 to 10 and then less than that. So this is my speed. Now if I focus upon cell radius. Now cell radius is more within the category of this much, and cell radius will decrease, and here at this end I have more decreased cell radius. Like I have 500 to 2000 meters cell radius within this range. So I can expect up to 100 to 200, whereas in this I will have less than 100 meter as a radius. Because frequency and a distance has inverse relationship, so as we are moving towards high frequency, my cell radius will keep on decreasing. And we can have even less than 50 meter in this also. And similarly, as I compare latency, I will also, so latency, I require the latency should decrease. So if this is a latency, it should decrease. So this is, as per my requirement, I require to purchase the bandwidth and from the spectrum. So this is the spectrum of 5G. Now what are the applications that driving 5G spectrum requirements? So we have applications the applications which require more spectrum as high resolution videos. This being the first requirement, that we require high resolution video, then we require virtual reality, and third application is augmented reality for gaming. We have self-driven cars. Then we have Internet of Things. Internet of Things, we have ultra fast connection speed. So as these are my requirements, those demand high spectrum or more spectrum. So in order to make these applications, that means we require these things to apply. So we require more bandwidth. That's why 5G requires more bandwidth concept and accordingly more spectrum to hold all of these applications being proposed or being promised by 5G. Now we have here in this 5G spectrum, we have a role of lower frequency and high frequency band. So we have role So we have a role of bands. That means we have low frequency bands and high frequency band. Now we have massively increased connectivity for network society. That means we have massively increased connectivity for society. Now that means if we want to have increase in capacity or increase in connectivity for society, so they all demand enhanced mobile broadband, which means enhanced speed. So that means we have a very flexible heterogeneous system. Flexible heterogeneous system. So why we have flexible heterogeneous system? Because we require connectivity as we require enhanced mobile broadband. In some areas we are focusing towards connectivity of that area, whereas in some areas we have enhanced mobile broadband services. So in all cases, what we require, what is our requirement? Our requirement is ultimately spectrum. So in order to provide connectivity as well as increase data rate, what we require a spectrum. Now we have a below 6 gigahertz, that means lower band concept, and above 6 gigahertz, that means high frequency band concept. So concept as below 6 gigahertz and above 6 gigahertz. So this below 6 gigahertz is low frequency band concept or low frequency band, whereas above 6 gigahertz is high frequency band. So that's why we have a role of high frequency and low frequency bands. Now this low frequency bands are used for building 5G ecosystem. So this is used for building 5G ecosystem. From ecosystem, that means seamless connectivity. So below 6 gigahertz, that means we require smooth migrations. So smooth migrations from LTE to 5G. So with the help of this low frequency band, we have smooth migrations from LTE to 5G. That means we can use the concept of carrier aggregation. So this is the role of below 6 gigahertz band. Now let's move to high frequency band. That means above 6 gigahertz. Now that means above 6 gigahertz is used to gain additional bandwidth. So this could be used to gain additional bandwidth. So we can have a concept of additional bandwidth with the help of this high frequency range. That means path loss between transmitter and the receiver should be proportional to frequency square. So in this case, my path loss should be proportional to frequency square. Now that means above 6 gigahertz from 30 or even 100. So this could be used for 5G latest applications, which are the demand or the proposed work of 5th generation. So these are the bandwidth concept that we have discussed in our class today. So this is all for spectrum class. We will continue with our next topic in our next class. Thank you so much.